This is Mr. Coker with Foundations of Algebra, Lesson 6.1, Solving One-Step Equations. So, if we're solving a one-step equation, the first thing to keep in mind anytime you're solving an equation is we're solving for a variable. So, that will take the form of a letter. You can see in all of these I used X. I like using that for consistency, but you might see a K, an M, a Y, any number of different things, of course. So, number 2, use inverse operations. So, we're going to see what operation is taking place, and we are going to do the opposite. Now remember, that means adding and subtracting are inverse operations. They're opposite each other. They're opposite operations. And multiplying and dividing are also inverse or opposite operations. And whatever you do to one side, you do it to both sides of the equation. So, we'll look at the first one. It says 3 plus x equals 10. 3 plus x equals 10. First thing I'm going to do is to draw a line down the middle of the equation, down the equal sign. The reason is each side of the equal sign are very distinct. We have to keep equations balanced at all times, because this side and this side always have to be equal. Sometimes putting an equal sign down the middle reminds you of this. It can help kind of visualize it a little bit. So, next, I'm going to look at what operation is taking place. I have 3 plus x equals 10. Well, now it says 3 plus x. We're not worried as much about the plus x. That's not the operation we're looking at. We're looking at the operation with the 3, because that's what we're removing. Well, we don't see a sign, and if we don't see a sign in front of the 3, we know that it's addition. Because if we subtract 3, we can eliminate it. So, another way to think of it, if we have 3 plus x, that's the same as x plus 3, if that makes sense. So, with the opposite, or the inverse operation of plus 3, again, is minus 3. So, whatever I do to one side, I do to both sides. On this side of the equation, I minus 3. So, on the other side of the equation, I also minus 3. Now, on the left side, I'm going to cancel out my 3's. I've noticed some teachers don't like the phrase cancel out. I like it because mentally I think it makes it a little bit easier. It avoids confusion. We bring down the x because it was unaffected. And then we have 10 minus 3, of course, is 7. And that's your answer. X equals 7. If that seems easy, it's because it is easy. Certainly with one step it's easy. So now we have 7x equals 35. I'm going to draw my line down the middle. But now I have some confusion, potentially, because it says 7x. Well, what does 7x mean? Hopefully you're like 7 times x, because that's what it means. Anytime that we see a number and a letter, or a variable, a number and a variable, next to each other with no sign in between, it means 7 times. Like in this case, 7x is 7 times x. So keep that in mind. We have an unseen, unwritten multiplication sign. It's understood. So we have to say, well, what's the opposite of multiplication? It's division. So I'm going to divide one side by 7 divide the other side by 7, because whatever you do to one side, you must do to both sides. By the way, I always like drawing the fraction bar. You can write it differently if it helps you. You can put a division symbol. Some students like that better. Personally, I like drawing the fraction bar. Now, 7 divided by 7 is 1. It's not 0. Like 3 minus 3 left us with 0, so we of course cancel it out. In this case, we're also canceling it out. And that's because 7 times 7 is 1. 1 times x, or 1x, is just written as x. So we don't have to worry about that. So anytime that we have this situation where we are dividing by the coefficient, it's canceling. So the x gets to come down because it is left. And then we do 35 times 7. Now, you can do that hopefully in your head or with a calculator. It will give you 5, and you're done. So x equals 5. Now, I'll do the last one. Another one that sometimes the way it's written can confuse students, and that is because sometimes people have trouble recognizing this as a division problem. Now, just like here, of course, I drew the fraction bar as a division sign. If you see something like x divided by 2, or x over 2, that's x divided by 2. It's a division. A fraction is written the way it is. It's written as a division problem. So, we have x divided by 2. What's the opposite of, or the inverse of, division? Well, if the inverse of multiplication is division, then the inverse of division, of course, is multiplication. And if you have trouble thinking about this, you can try the different operations. For instance, if we do the times, so we do 2 times x over 2. Well, I forgot to draw my line. Sorry about that. And then on this side, I do times 2 as well. Well, on this side, 2 divided by 2, well, just like 7 divided by 7 canceled, 2 divided by 2 will cancel. That had no meaning about it. It was just a squiggly mark I made by accident. But the 2 divided by 2 cancels, brings down your x, and then we've just got the x by itself. Now we have 14 times 2 is 28, and we're done. And that's it. So, hopefully, these are pretty easy. They're one-step equations. The key to them is just recognizing what operation is taking place, recognizing what the inverse operation is, and then doing it the same to both sides. So, here's your examples, and have a nice day.